It's important to realize that the point of an integration test based on a sequence diagram is not simply the end result. In this example, there's a sequence diagram that shows a vending machine that takes 2 coins for a purchase, receiving a third coin and refunding it automatically, going back to 2 coins inside the machine ready for a purchase. The integration test for this sets up the machine, makes sure that the machine thinks it already has 2 coins, and then pops in another coin. That initiates the test. The remainder of the test is observing the coin-in signal arrives, the coin count increases and it thinks it has a third coin, then it refunds the coin by exercising the coin out actuator, and the coin count goes back to 2. Simply looking that the final coin out is 2 is not how you determine pass-fail for this integration test. This integration test only succeeds if it notices it has an extra coin and it refunds the extra coin instead of just silently eating it, and then goes back to the right number of coins. Only observing the final test output would not tell you whether it actually refunded the coin, which is the whole point of this sequence diagram and this integration test. What this example illustrates is that integration test is not simply a pass on the final output, but rather, did all the arcs appear in the expected sequence? Did all the timings happen as you expected? Did all the side effects happen as you expected? In other words, it is not simply that the pieces managed to work together more or less. It's that they managed to work together exactly as they're supposed to according to the high-level design.